Yes, good afternoon, all of you. Sorry, there was a small error. The link was not being able to connect you. I have created a new link and I've sent it to you on WhatsApp. Please tell your friends to get in, get connected, call them if required. Okay. So, and I hope we are good to go. Yes, others have not yet joined. Only 5 to 6 children here. Where are the others? Can you just ask them to connect? Okay, so fine, let them connect on the go. Okay, all of you can hear me. Just raise your hands if you can hear me. Raise your hands. All of you can hear and see the video. Raise your hands, all of you. Yeah, good, good. All right. So let us focus on uh, today what we are going to do in chemistry. Okay. So yeah, yeah. In our last session, we did about ionic bond in detail, and we also did about covalent bond, right? Today, we have to start with polar covalent bond. Last time, I had introduced you to something called as your four types of chemical bonds and the physical bonds, right? Physical bonds, which all were there. We were having polar dipole-dipole moment. We were having a dipole-induced dipole. Then we were having hydrogen bonding, van der Waals forces, or London forces, or dispersion forces. So they were your physical bonds. In chemical bonds, we were having polar covalent bond, we were having ionic bond, we were having covalent bond, and coordinate bond. So out of these four, we have finished with two. The remaining two we are going to do today, and then we'll move on to the physical bonds. Physical bonds, chemical bonds you have done in your lower classes. I'm going to give you a little extra pinch of salt with that. And after that, I'm also going to tell you about your uh, physical bonds. Okay. So let's start. Okay. Just a second. Just a second. Huh? I'll just drop in a message on the group telling them to join. Yes, some more I've connected now. I think. Yeah. So let us start. क्या बात कर रहे थे हम लोग केमिकल बॉन्ड्स में फिजिकल सॉरी पोलर कोवैलेंट बॉन्ड की राइट लेट अस डिस्कस विद कोवैलेंट बॉन्ड एक बार आपको रिवाइज करवा देता हूं लगा तो we had seen covalent bond Cl2 Cl2 was Cl and Cl, where chlorine was having atomic number 17 with electronic configuration 287. With electronic configuration what? 287. Right, 7 meaning 7 electrons in the outermost shell, 1, 2, 3, 4, 5, 6, and 7. Similarly, we were having 1, 2, 3, 4, 5, 6, and 7 electrons. So 7 electrons in the left chlorine, 7 electrons in the outermost shell of the right chlorine. So both are having 7, 7 electrons. Okay, both are having 7, 7 electrons in the outermost shell. So now they are playing tug of war because दोनों chlorine की जो electronegativity है वो equal है, that is 3.5 and 3.5. So both are playing a tug of war. So here this chlorine also wants to attract electrons and that chlorine also wants to attract electrons towards itself. Both the chlorine atoms want one electron in order to satisfy the octet, like they were wanting to do it in ionic bond. So what is going to happen here? They because they are having equal forces of attraction, because they're having equal forces of attraction, we are having something called as END. What is END? END is electronegativity difference. So 3.5 minus 3.5, the answer is what? 0. What is the answer? The answer is 0. So 3.5 minus 3.5, the answer will come equal to what? 0. So that is the END, electronegativity difference, right? Electronegativity difference. Okay, all of you with me? Hello, all of you with me? Raise your hands. All of you, are you with me? Raise your hands. All of you with me? Just lower down your hand and raise it. Yeah. Okay, fine. Great, great, great. Okay. So END 3.5 minus 3.5, that is equivalent to 0. You can lower your hands, no problem. Right. So this is 3.5 minus 3.5 equal to 0. So both are playing a tug of war. Now, which chlorine will win? No chlorine will win because they are of equal, what do you say? Equal strength. They are pulling the electrons equally. So as they are putting the electrons with equal strength, right? मैं भी रानी तू भी रानी कौन भरेगा घर का पानी? Two equally powerful teams playing tug of war. The electrons will not go over here, nor over here. They will remain in the center. The electrons will remain in the center. So when the electrons remain in the center, we can draw the two chlorine atoms like this. Okay, we can draw the two chlorine atoms like this with one Cl over here, another Cl over here. Now they are having 1, 2, 3, 4, 5, 6, 7 electrons, and this one 1, 2, 3, 4, 5, 6, and 7 electrons. See, in your ionic bond, it's compulsory to show all the shells, first shell, second shell, third shell, right? But in covalent bond, it's okay if we show it with the outermost shell also. So can you see this overlap? Like if you've seen Venn diagrams in math, so it's that kind of thing. So this overlap is showing these two electrons. These two electrons will be shared in both the atoms, in this atom also, in this atom also. It will be shared in both the atoms. So this pair of electrons are the bonding electrons. Hence, they are associating both the chlorine atoms. They are bonding both the chlorine atoms. That's why they are called as bonding electrons. And the remaining, they are not participating in bond formation. The remaining are not participating in bond formation. Hence, they are called as non-bonding electrons. What are they called as? Non-bonding electrons. Right? What are they called as? Non-bonding electrons. So bonding electrons and non-bonding electrons. Clear with this? Yes, all of you raise your hands. Clear with this? If you're clear, raise your hands. Yeah, Dhruv is clear. Others also clear. Yeah, everybody is clear. Okay, so fine. So this is what bonding electrons and non-bonding electrons. What are they? Bonding electrons and non-bonding electrons. Fine. So bonding and non-bonding electrons. Now, after we are having this bonding and non-bonding, we will now step into. Now we will move on to, after bonding, non-bonding. This is a covalent bond, right? ENT is 0 or close to 0. That is covalent bond. Now let us move on to, we had done this last time. Now let us move on to PCB, polar covalent bond. Okay, polar covalent bond. Now what is this polar covalent bond? Tell me quickly, what is polar covalent bond? Right, I know you cannot unmute yourself, but you can say it to yourself, what is polar covalent bond? Now let me tell you, let me draw that this line. Which line? Imaginary line of what? Your scale, imaginary scale of what? Your END, imaginary END scale. So in that imaginary END scale, we are having 0.9 in between as polar covalent bond. If the END is 0 or close to 0, it is covalent bond. And if the END crosses 1.8, that day I told you if the END crosses 1.8, the bond is ionic bond. The bond is what? Ionic bond. Yes, the bond is ionic bond. Okay, so I hope you are able to see this on both the ends. If it's 0 or close to 0, the bond is covalent bonds. If it's 0.9, the bond is a polar covalent bond. And then we are having what? Ionic bond. Okay, then we are having what? Ionic bond. Okay, beyond 1.8. So we have finished with covalent. We have finished with covalent. We have finished with ionic. We are now supposed to focus on polar covalent bond. Okay, so let us see what is this polar covalent bond. Okay, let us see what is this polar covalent bond. So polar covalent bond is actually a mixture. Okay, technically it is a mixture of covalent and ionic bond. It is having properties of both covalent and ionic. Let me give you a classical example. Have you heard about the pink color? Pink color is a mixture of red and white. When you mix red and white together, it will become pink. But can you say that pink is completely red? No. It, it is having little bit of redness, little bit of whiteness. So it is not completely red. Can you say it's completely white? No, it's not completely white. Similarly, polar covalent bond, can you say that it's completely covalent? No, it's not completely covalent. Can you say that it's completely ionic? No, it's not completely ionic. It's having some tinge of ionic, some tinge of covalent. It's in between covalent and ionic. Right? It is in between covalent and ionic. It's polar covalent. Right? So it is having properties. Some properties of it will be of the covalent bond. Some properties of it will be of the ionic bond. Let us see how. Okay, so HCl, we are having over here H plus and Cl minus, H plus and Cl minus, if it is ionized, right? Plus and minus if it is ionized. If it is not ionized, I hope you remember what is ionized. We have seen in 10th standard electrochemistry, ionization, dissociation. There we have seen ionization, dissociation. So if it is not ionized, then it will be having delta positive and delta negative charge. What do I mean is that here, say for example, this is for chlorine, equal sharing, Cl, equal sharing. They are equally sharing. This equal sharing meaning covalent bond. Equal sharing है तो क्या हुआ? It is covalent bond. Equal sharing, covalent bond. Okay, equal sharing is covalent bond. Then if it is about hydrogen and chlorine, then it will be something like this, where hydrogen gets a smaller share. It is sharing, but hydrogen gets a smaller share and chlorine will get a larger share. You can see chlorine is getting a larger share. Okay, chlorine is getting a larger share. Okay, so last year we had taken the example, I had explained all this to you, chemical bonding last year also, because it was there in your 10th standard, right? And now physical bonds, after this, which we are going to do the physical bonds, that is going to be the very first time, because physical bonds were not explained to you in your 10th standard. It is a part of your 11th standard. Okay, although chemical bonding is also there in your 11th standard. Okay, so here hydrogen will gain a smaller share of electrons, gaining a delta positive charge, because electrons are having a negative charge, right? So more electrons, who's gaining more electrons? Chlorine is gaining more electrons. And that's why it is having a delta negative charge. And what about hydrogen? Hydrogen will gain a delta positive charge. Let me give you a classical example. Classical example about two sisters, Savni and Saloni. Okay, two sisters, Savni and Saloni. Are they with us? Let me check. Are they with us? Savni and Saloni? No, they're not connected. Maybe they were not aware of the timings. But anyway. Okay, so let us take two example of two sisters, Savni and Saloni. And here, say for example, Mama gives an apple to Savni and Saloni, and that apple they cut, because they are twin sisters. They will cut the apple in such a way that both of them will get half. So which bond is formed? Obviously, covalent bond is formed. Which bond is formed? Covalent bond is formed, right? But if if say for example, Savni was the younger sister and Saloni was the elder sister. So what would Savni do? Savni, because she's the elder sister, she will cut the apple in such a way that Savni gets a larger share and Saloni gets a smaller share. So in this case, what is going to happen? In this case, the one who's got a lesser share will gain a delta positive charge, and the one which has got a greater share will get a delta negative charge. Means the greater piece of apple has been given to or been taken by whom? Taken by Savni, greater share. Saloni is getting the smaller share. Chilka bhi nikal ke diya, so it will be what? Sharing only, but the sharing is not equal. The sharing is not equal. So this is unequal sharing, and unequal sharing is only the polar covalent. Unequal sharing is there. That is only called as what? Polar covalent bond. Right? Are you able to see this? Unequal sharing is called as what? Polar covalent bond. Are you able to see this? Raise your hands. Are you able to see all this? Are you able to understand and see as well? Raise your hands. Yes, all of you, or those who are able to understand and see. Anybody who's not able to understand, type something in the comment box, or not in the comment box. You're not allowed to do that. You can do it in the question answer section. If you have not understood anything, type your question in the comment box. I'll be able to answer that. I'll see it right away and I'll answer it. Okay. Yes, Dhruv, if you are having any question, you can just type it in the comment box or in the question answer. There is a question answer tab over there. Click on that. I'll be able to see your questions. Okay. So this is unequal sharing, right? This is what unequal sharing. And because of unequal sharing, what bond is formed? Polar covalent bond is formed. So as I was telling you that your polar covalent bond is formed because of unequal sharing. And I also told you that it is a mixture of ionic and covalent bond. So now what features is it having of the covalent bond? See, it is sharing, although it is unequal, but still it is sharing. So sharing is a feature of covalent bond. So sharing is a feature of covalent bond. So this feature of covalent bond it is using, and charges is a feature, or poles meaning the charges. Charges is a feature of ionic bond. So it is having ionic bond as well, right? It's a mixture of both. So it is having charges. It's like it's a feature of ionic bond. It is sharing electrons. That is a feature of covalent bond. So it is having both the features. It is having both the properties of covalent as well as ionic. That is why it is in between, right? That is why it is in between. Between of what? You can see over here. That is why it is in between of E and D scale. It is a mixture of covalent as well as ionic. It forms polar covalent bond. Just like the pink color forms, it's a mixture of red and white, which is forming pink. Similarly, if I would like to give you another example of transition, or you can say the intermediate color, is like you're moving out of the house, right? Please don't move out of the house right now. But if you're moving out of the house and I click a photograph over there, and when I click a photograph over there, what will you be able to see? We'll be able to see in that photograph that 1 foot is outside the house, 1 foot is inside the house, and that is the point where I've clicked the photograph. That means you are not completely out, you're not completely in. You're not completely out, you're not completely in, you are in between. So that is the transition, and that transition is being shown in polar covalent bond. Right? That transition is being shown in polar covalent bond. Understanding this? Yeah, all of you understanding this? Raise your hands, raise your hands. Yes, raise your hands if you're understanding. Till here, no problem. No problem if you have understood the entire thing. And if you have not understood any particular thing, or if you want me to repeat, just write it in the question answer section. Write in the question answer section. I'll be able to read that and answer. Yes, Umema, if you have any question, you can write in the question answer. I hope each one of you is understanding. Ansh, Dhruv, Dhruv Gupta, Dhruv Chotalia, Dia, then Gayatri, Neeraj, Umema, Vedashri. So happy to see only sincere and serious students. All other crap is gone. Okay, so happy to see all those who are sincerely ready to learn. I hope the voice is not cracking in between. It's not lagging. The video is also not lagging. Everything is moving perfect. Raise your hands for that. If there is any problem, just notify me in the question answer section. Yeah, everything is working. Yeah. Okay. All right. All right. All right. I've got your response. Great. So, fine. So we have completed the polar covalent bond. Now let's move on to the next, that is coordinate bond. Let's quickly do that coordinate bond and let's rush to your physical bonding, which is like physical bonds are new to you. Okay, just let's move on to covalent. I have sorry, because coordinate, and after coordinate we'll move on to physical bonds. So have a look over here. We are going to write what? बोलो क्या लिखने वाले हैं अभी? We are going to write about coordinate bond, that is the D point, last point, coordinate bond. Okay, so in this coordinate bond, we are having like ammonia. Classical example, ammonia. If you want, I can explain you with the help of ammonia. Also, we can do it with H3O plus, right? Hydronium ion, formation of hydronium ion. That also can be explained. Okay, so ammonia plus we are adding HCl. Here your HCl is ionized, not It is not in the polar covalent bond. It is ionized. Already ions have been formed. So this hydrogen is literally without any electrons. Okay, Vidashri, this hydrogen is without any electrons. Ansh, this hydrogen is without electron. Okay, and the hydrogen which is without electron is also called as proton. क्योंकि हाइड्रोजन का कैसा रहता है कि हाइड्रोजन is having only one proton and one electron. It does not have a neutron. It does not have a neutron. Always, hydrogen does not have a neutron. Atomic number one, the lightest element, it does not have a neutron. So electron can be thrown out. Okay, if electron can is given is if hydrogen donates an electron to an electron acceptor, then hydrogen will be left with zero electrons. Okay, hydrogen will be left with zero electrons. So अभी ना तो इसमें प्रोटॉन है, ना तो इसमें इलेक्ट्रॉन है, ना तो इसमें न्यूट्रॉन है, बचा सिर्फ एक प्रोटॉन है. इसके लिए H+ आयन को हम लोग प्रोटॉन भी कहते हैं. ओके, H+ आयन को प्रोटॉन भी कहते हैं. वाई H+ आयन को प्रोटॉन कहते हैं? क्योंकि इलेक्ट्रॉन दे देने के बाद में ना ही उसमें इलेक्ट्रॉन बचता है, ना ही न्यूट्रॉन बचता है. क्या बचता है? सिर्फ एक प्रोटॉन ही बचता है. ओके, so let's move on. NH3 plus HCl, just let me erase this. Okay, so yeah, NH3 plus HCl. So this hydrogen is without electrons. So what will happen? This nitrogen is there in the center. It is having NH3 का ये structure है, right? Nitrogen का atomic number 7 है. Electronic configuration 2,5. So it's having 1, 2, 3, 4, and 5 electrons over here. How many? 1, 2, 3, 4, and 5 electrons over here. So we'll be sharing electrons of hydrogen. Hydrogen will be sharing electrons with nitrogen. And this is a covalent bond. Which bond is this? This is a covalent bond. This is what? A covalent bond. Okay, and the lone pair of electrons will be given to hydrogen. Lone pair of electrons will be given to hydrogen, and when it is given to hydrogen, what will happen? Right, these lone pair of electrons will be accepted by hydrogen. It will form NH4 plus. It will form what? NH4 plus and Cl minus. Okay, so this hydrogen, ये hydrogen क्या बोल रहा है? जैसे ये hydrogen अटैच हुआ यार, मेरे को भी अटैच होना है, मेरे को भी इसके साथ में बॉन्ड फॉर्म करना है, पेयर करना है. So this hydrogen gets attached with the nitrogen. It forms NH4 plus Cl minus. That is ammonium chloride. Right? Ammonium chloride. What is that form? Ammonium chloride. Okay. NH4 plus Cl minus. NH4 plus Cl minus. Getting this? NH4 plus Cl minus. Okay. Now example. Example ये है कि say for example we are having here two Dhruvs we are having with us. We are having Dhruv Gupta, Dhruv Chotalia, right? Dhruv Gupta and Dhruv Chotalia. Okay, so Dhruv G and Dhruv C both go to a coffee shop. Both have a cup of coffee, right? One cup of coffee which is shared half by Dhruv and half is shared by Dhruv Chotalia. Okay. So Dhruv Gupta, Dhruv Chotalia, both are having half of coffee. Both are drinking 50-50%. Both are paying for it 50%. Say for example, the coffee is for 40 rupees. So he's paying 20 rupees, he's paying 20 rupees. So obviously by now you have understood that the bond formed over here is a covalent bond, right? The bond formed over here is covalent. They're sharing equal sharing of the coffee, equal sharing of the money as well. Okay. So after this, what happens is that next time again they go. And after they go again, what happens is that next time Dhruv, okay, who was there on the left side? Dhruv Gupta was there on the left side. So Dhruv Gupta pays 40 rupees just because both of them have half of coffee again, okay, on the next day. But Dhruv Chotalia forgets money at home, and Dhruv Gupta pays for both of them, Dhruv Chotalia as well as himself. Why? Because he has forgotten the money at home. Both have taken half of coffee, but who has to pay for it? Only Dhruv Gupta will pay for it. Dhruv Gupta, don't worry, Dhruv Chotalia will return it to you the next day. Okay, so 40 rupees has to be paid by, well, 40 rupees has to be paid by Dhruv Gupta only. Why? Because Chotalia has forgotten the money at home. So what is happening over here? Same thing is happening over here. When NH4Cl bond is forming over here, this NH4Cl bond is something like this. Have a look. This is NH4Cl. Now, out of these bonds, all these are covalent. These three are covalent, right? These three are covalent, but these are what? Coordinate. This is which bond? This is the coordinate bond. Coordinate bond, why? Because see, both are sharing the electrons. Who both? Both nitrogen and hydrogen are sharing the electrons. But who's paying for the money? Who's paying for the electrons? Only nitrogen is paying for the electrons. Because hydrogen was as it is, it was not having a single electron. So both are sharing the electrons, but who's paying for the electrons? Only nitrogen is paying for the electrons. So as only nitrogen is paying for the electrons, what will happen? Coordinate bond will form, and this is called as ammonium chloride, NH4 plus Cl minus, and this Cl minus will be here outside. This will form positive. The nitrogen will gain a positive charge, chlorine will gain a negative charge. So positive and negative, there is an ionic bond. So this is a bond which is having, this is a compound which is having all three types of bonds. It is having ionic also, it is having covalent also, and it is having coordinate also. It is having all kinds of bonds, right? It is having all kinds of bonds. Okay, understood? Yeah, did you understand till here? Yeah, raise your hands, raise your hands. Yeah, yes. Yeah, almost. Yeah, those, see, not everybody is raising the hands. Almost all of you are raising hands, but one or two are not raising the hands. So what should I understand? So ones who are not raising their hands, you, if you have not understood anything, put your question in the Q&A. Q&A, just put your questions over there. There is a tab Q&A, right? Put your questions over there. Yes, Dia, thank you. Okay, so fine. Now we will move on to the next point. Now we have finished. See, now we have finished covalent bonds. Okay, now we have finished covalent bonds. Now we sorry. Now we have finished chemical bonds. Right now we have finished chemical bonds. Now you move. Now we will move on to physical bonds. Okay, now we'll be moving on to physical bonds. So after finishing the chemical bonds, we are now going to move on to physical bonds. But before moving ahead, I would suggest that you quickly do a revision of the covalent bond, ionic bond, polar covalent bond, coordinate bond. Quickly do a revision of these four bonds. Okay, quickly do a revision of these four chemical bonds. Then we'll start with physical bond. And physical bond is even more interesting than your covalent bonds, or sorry, chemical bonds. So we'll have a look, just quickly revise, and then we'll see. I'll give you 1 minute. Yeah, I hope you all have revised. Yes, I all have gone through. Yes. All of you have gone through these chemical bonds. Okay. In case you have not gone through it, do it after the session. And now we shall move on to the next point. That is, as I told you, physical bonds. Right. Let's move on to physical bonds. Let's dive in deep into physical bonds. It's going to be more interesting. Physical bonds. Let's see. Okay. All right. So in physical bonds, okay, in physical bonds, we are having, please pay attention. I'll just enlist once again the physical bonds, and then we are good to go, like dipole moment. Okay, dipole moment, dipole, then dipole, dipole induced dipole, dipole induced dipole. Then we are having iron dipole. Okay, iron dipole. Then we are having, as I told you, hydrogen bond. Okay, hydrogen bond. So two types, inter and intramolecular hydrogen bond, intermolecular and intramolecular hydrogen bond. Okay, intermolecular and intramolecular hydrogen bond. So dipole induced dipole, iron dipole. Okay, then hydrogen bond two types, intermolecular and intramolecular. Yes, Dhruv, have any question? If you don't have any question, you can lower your hand or put your question in the Q&A section. Okay. Then we are having the next bond, that is after hydrogen bond, we are having the next one, that is van der Waals forces. Van der Waals forces, also called as below. Van der Waals, also called as tell in your own mind over there. Yes, it's also called as London forces and dispersion force. London forces, also known as dispersion forces. Okay, van der Waals forces, London forces, dispersion forces, right? So these are what? These are your bonds, right? What are they? These are your bonds which are available. Okay, these are the bonds which are available. Okay, which are physical, which are the types of physical bonds. So let us dive in into each and every point. Let's go deep into dipole interaction and see what is there in dipole. So remember, these are physical bonds. These are seen in elements. Okay, mostly seen in elements, and they don't involve any chemical interaction. Meaning they will not involve the exchange, transfer of electrons, sharing of electron. They will not be, you can say, like coordinate bond, giving electrons to the others. There will not be, unequal sharing also of electrons. So sharing, transfer, no, nothing. Okay, here it's going to be a little different. Let's see how it's going to be. Okay. So first point we'll pick up, that is dipole interaction. So first of all, what do you mean by dipole? Right? What do you mean by di? Di meaning two. Okay. Di means what? Two. Pole meaning what? Charges. See, poles, the positive pole, both as a positive pole, negative pole. Pole meaning charges. Right? Pole meaning charges. So two, and pole meaning what? Charges. So it is having, the one which is having two charges is called as dipole. The one which is having two charges is called as dipole. So dipole interaction meaning two compounds which will be having poles, both the charges, and they will be having attraction between them. Let's see how. Okay, say for example, I'm having HF. Now, fluorine is the world's most electronegative element, correct? Fluorine is the world's most electronegative element. And as fluorine is the world's most electronegative element, ladies and gentlemen, as fluorine is the world's most electronegative element, fluorine will pull electrons towards itself. Yes or no? Fluorine will pull electrons from hydrogen, like chlorine was pulling electrons from hydrogen. Even fluorine will pull electrons from hydrogen, because even fluorine is even more electronegative than chlorine. So it will pull electrons from hydrogen, and it will gain a delta negative charge, and hydrogen will gain a delta positive charge. Similarly, we are having one more HF where fluorine will gain delta negative and hydrogen will gain delta positive. Same thing, two molecules, two identical molecules, HF, HF. Now, what will happen between this HF and HF molecules is that these molecules will develop an interaction or attraction for each other. Why they will develop an attraction for each other? Yes, why they will develop an attraction for each other? Because it's very simple. This is delta negative, this is delta positive. Unlike charges attract each other. Unlike charges attract each other. So see, remember, we are not talking about this bond. This bond is your chemical bond. This bond is your chemical bond, PCB, polar covalent bond. We are not talking about the bond between hydrogen and fluorine. Please get this clear. We are not talking about the bond between hydrogen and fluorine. We are talking about the bond which is in between HF and HF, between two HF, and it will continue between one more HF. If you have one more HF over here, it will continue, right, Vedashri? It will continue as HF, one more HF, delta negative, delta positive, one more HF. So HF, 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 they will have what? These HF will hold on to each other. They will have what? Dipole-dipole interaction. You are having one dipole, you are having another dipole. Both the dipoles are having interaction with each other. Both are attracting each other. So this is a physical bond. It is not a chemical bond. It is not a chemical bond. There is no electron transfer. There is no electron sharing. There is no equal sharing. There is no unequal sharing. There is no coordinate bond, both paying for the same atom paying for both the electrons, both the atoms, nothing like that. So this is what your dipole-dipole interaction. What is this? This is dipole-dipole interaction. I hope you are understanding this, each one of you. All of you with me? Raise your hands. All of you with me? Yeah. Only Dhruv has raised his hand. Yeah. Others are also raising. Yes. Correct. What about more 4-5 students who have not raised? Yes. Good. So you all have understood what is dipole-dipole interaction. Okay, dipole-dipole interaction is the first. Yes, Vedashri, thank you for raising your hand. Okay, so dipole-dipole interaction. So dipole-dipole interaction is, below dipole. There is a question over here. Yeah, sir, can you please explain this again? It's given by Dhruv. Sure, Dhruv, I'll explain it again to you. No problem. Okay, so pay attention. Now, this is one dipole. Okay, first of all, what is the meaning of dipole? Come back again. What is the meaning of dipole? Di meaning two, pole meaning charges. So we are having two charges, right? We are having two charges. That is meaning of dipole. So dipole, एक dipole होगा जिसमें दो charges होंगे, ये दूसरा dipole होगा जिसमें और दो charges. So dipole के बीच में attraction होने वाला है. As simple as that. So if I take HF, here I've taken HF. Let me take another example of HCl. No problem. HCl भी चलेगा. Hydrogen will be having delta positive charge. Some few minutes ago only we have seen that yes, HCl is having these charges, delta positive, delta negative. That is the polar covalent bond. Okay, so we are not talking about polar covalent bond. We are talking about we are not talking about the attraction between hydrogen and chlorine, but we are talking about the attraction between two HCl molecules. Earlier in chemical bonding, we are checking about the attraction between atoms. Here we are checking about the attraction between molecules. Okay, so check out. Now we are having HCl, one more HCl molecule. Again, this hydrogen will be delta positive, delta negative, because chlorine is more electronegative, of course. Hydrogen is less electronegative, so it will gain delta positive charge. Now this delta positive charge will attract the delta negative hydrogen. Why it will attract? Simple. Unlike charges attract each other. Like charges repel each other. You have seen this in your lower classes, isn't it? Okay, so unlike charges attract each other, that's why they will start attracting each other. This is how, this is one dipole. So I will write over here dipole. This is one dipole. This is another dipole. So this is dipole interaction, right? Dipole interaction or dipole bond, physical bond. Dipole interaction or dipole physical bond. Yes, Dhruv, did you understand? Raise your hand. Did you understand now? After explaining it again? Yes, you have understood it now. So we have raised your hand. Fine. So now let's move on to the next point. That is the second bond, the second physical bond, that is dipole induced. Now this is very interesting. Try to understand dipole induced dipole. Okay, there's a question. Sir, can you please? Umema says, so does the hydrogen of first dipole attract the chlorine of the second dipole and vice versa? Yes. You understood it right. Umema, you understood it right. Okay, what you are saying is right. Okay, Umema, fine. So now let's move on. Any further clarification, Umema? If not, just raise your hand. Umema, just raise your hand. Yeah, great. Okay, so you have understood it completely. Fine. Now the next bond is very, very interesting. It's a dipole induced dipole. Now I want to tell you what is dipole induced dipole. Say for example, I don't have any objects, so I'll just take this. or maybe I'll just take the key. Okay, yeah. Okay, so you can actually see this. I'll try to show this to you. This is the pack of the earphones. Okay, and it's magnetic. ठीक है, इसको मैं ये इसको लगाऊंगा तो it will attract, right? Yeah, it is attractive. Okay, so what is happening is this is getting attracted to this. Okay, so this is having a magnet, and this is magnet. Okay, this one is magnet, and this is your metal object. So I keep this in contact with each other, right? So this a magnetic object is getting attracted to this for a long period of time. Okay, it's getting attracted. This is simple magnetism. If I keep this in contact, say for 1 month, if this magnetic material is kept in contact with magnet, like iron object is kept in contact with magnet for 1 year or 1 month, then what will happen? This will also start behaving like a magnet. Although this is not a magnet, this was not a magnet, but now because it was kept in contact with the magnet, it started to behave like a magnet. Right? It has started to behave like a magnet. So this is called as induction. What is this called as? Induction. So this is dipole induced dipole. Okay, that meaning of this is what? Dipole induced dipole. Check. Dipole induced dipole. Dipole induced dipole. That means HF is there, it is having the dipole. Okay, HF is there, it is having the dipole. We are having CH4 over here. CH4 is not having the dipole. CH4 is not having the dipole. Only HF is having the dipole. But just because CH4 is kept in contact with HF, CH4 in case is kept in contact with HF, the dipole character is induced in CH4. Okay, just like magnetic property or magnetism was induced in the iron object, right? Just like magnetism had been induced in the iron object, similarly, this charges wala feature is induced in methane. Or see, methane is non-polar. Methane has got nothing to do with charges. But just because it is in contact with HF, fluorine will start pulling electrons of carbon also. Carbon will gain delta positive charge. This will gain delta negative charge. So it will start attracting. It will start developing charges, and then they will attract each other. So when they are attracting each other, they are attracting only after dipole character has been induced. Induction has been taking place over here. What has taken place? Induction. Just like how induction takes place, in magnet. Like if you keep an iron object in contact with magnet, how magnetism is induced in that. Similarly, this was not having charges. It was non-polar. Non-polar, when kept in contact with polar, the charges got induced in them, and after the charges got induced in them, they started attracting each other. And once they started attracting each other, the bond which is formed is called as dipole-induced dipole. Have you understood? Have you understood? Raise your hands. Have you understood? If you have understood, raise your hands. Yeah. Yes. So almost all of you have raised your hands. One is like either inactive or not paying attention, maybe. So question answers में अगर आपको नहीं समझ में आ रहा है, please post your questions and question and answers. It's 4:05. It's actually 4 o'clock is the time. Yeah. Thank you, Diya. Okay. Thank you, Diya, for understanding and raising your hand. So we have it's time for I'm getting messages from the next class. My next class was supposed to start at 4 o'clock for another standard. That's why I shifted your timings earlier. Okay, but now don't forget to connect. All of you, please connect for maths at 5 o'clock sharp. At 5 we'll be starting with maths. So all of you, please connect for maths. Okay, so very good afternoon and thank you. I hope you have understood. We'll be continuing with the further polar bonds in our next class. So further physical bonds in our next class. So good afternoon and thank you. Have a nice day and evening ahead. I'll end this session.